Our next speaker is Stephane Pinel, and he is the head of data science at Mailchimp. And Stephane is probably the most, we probably have the strongest connection of all the speakers. We have 40 mutual connections that we've amassed over our experience. He has a PhD in electrical and computational engineering from a French university that I absolutely cannot pronounce. He's a former CTO, and he used to be at a really cool company called Logic Blocks, where I know a lot of people from there too. His term is customer-obsessed AI, so please welcome Stephane.
Thank you very much. Welcome. So I'm Stephane Pinel. I'm leading data science at Mailchimp. Our strategic vision is Mailchimp is like having your own marketing team. So I'll explain what we do. So today I'm going to make a brief intro about Intuit and Mailchimp. Just one corporate slide, I promise. And then describing a little bit the wide range of activity we have at Mailchimp. And then I will focus on a subset of that activity related to how we approach using a large language model like GPT-3, but could be others, for short and long text generation for marketing. And as well, how we improve this model when the level of requirement is getting higher. So first of all, Mailchimp is an all-in-one marketing platform. We help our user grow their business through a lot of different marketing tools. Historically, email marketing is the core value proposition of a Mailchimp, but we have extended this to a lot of different channels now. And recently, Mailchimp got acquired by Intuit, which is really interesting because when you look at the offering from Intuit, which is really focusing on running your business, the back-end office side of it, combining with growing your business with Mailchimp. Now we can provide, with this ecosystem, a unique platform, a unique solution to small business and mid-market size business, which is our target, and achieving the mission of Intuit, which is powering prosperity around the world. So Mailchimp is like having your own marketing team. This is how, in the data science team, we looked in a very customer-obsessed way about the customer problem, right? And the way to look at that is like, put yourself in the shoes of our customer, like small business owners, right? They wear 1,000 different hats. They have like a lot of different tasks and jobs to do every day. And as they grow their business, one of the most important questions they have to ask themselves and solve strategically is, who are you going to hire on your team? Who do you need? Who are the skill sets they need, right? So obviously, the first things you need when you do marketing, you need a marketing expert, right? Someone who can look in the data and know all the marketing practice and in a data-driven way can tell you how to optimize your marketing outcome, right? And this, digging into the data can turn into recommendation. What are the best recipe for this? What are the best automation? At every step of the way, what are the things that will drive a better marketing outcome? So we have a lot of activity around that. Also, once you know this strategy, you need to use tools and platforms. So you probably need also a marketing a tool expert, like a Mailchimp expert, that will help you navigate it through the platform. So we do a lot of user behavior modeling, like churn and propensity of various sorts. Also sequence modeling, next text prediction, etc. And the goal there is to really understand our user, what they do in the app, and automate basically nurturing through the app so that they can be redirected to the right place at the right moment, right? Very quickly also, once you have your marketing strategy, you're going to face the problem of generating content. That's at the core of any marketing activity, and you're going to need probably someone who writes really, really well, right, like a copywriter. So AI obviously lends itself very, very naturally there. So we use models like BERT, NT5, and also GPT-3 for assisting our user in their generation. So think about preview text and subject line. I'll talk a little bit about that today. That's going to be the focus of the talk. We also do a lot of activity in terms of image processing and image assistance. So using models like Clip and DALL-E. It turned out that this is a very time-consuming task that our users have to do, right? Often they go out and go in Photoshop and then they have to come back, right? Whereas we can assist them right on the spot and speed up their process with things like, for example, background remover or image extension. As I mentioned, Mailchimp is also now a multi-channel platform. We don't offer just email, but also services like survey, inbox, and SMS. And it's an overwhelming amount of data for our user to process on a daily basis. So we can assist them, like process this data, analyze this data for them, trigger some event for them, and use AI text assistant for that. Last but not least, our user also has to manage their audience, their customer, right? And the more they understand about their customer, the better they can do their marketing for this. So a lot of data analysis and also a smart segmentation project that we have to personalize at the subscriber level the message marketing they can send to them. So that's, in a nutshell, everything we do at Mailchimp in the data science team. So today, I will focus on the copywriting piece of it, right? You have all heard about GPT-3 and all of this very exciting large model that have been developed recently. The key question is, how do you really bring that to production? How do you really make that accessible and useful for our customer? So we are all in the scientific bubble here. So we know about this model. We are starting to get familiar with this. But in the small business world, that's not how it works. And so we need to really understand how we can use this and bring the technology to meet our customer where they are. So some example of short-form text assistants that are very useful, for example, subject line, preview text, header, and subheader. And so historically, we started there a few years ago with like a model like BERT, and then we upgrade to T5. Currently, we are evaluating if we upgrade to GPT-3. Actually, T5 so far works really well because we have also a large amount of data that we can filter using performance campaign and create high-quality per data set to optimize and fine-tune a model like T5, so that from an email campaign, we can perform summarization task and generate this very short form text, right, that actually is very short summary of the main content. So this works really well. This is working in production already. One interesting example is that beyond just like providing assistance in the email editor, you can also take that and use this as a gateway to multi-channel marketing campaigns. So for example, as you work on an email, as you create a subject line or a subheader for your email, you can also take that content and combine this with some layouts and creative tools that we have developed on the platform as well to create other content derived from there for another channel, let's say a social post that's going to be much shorter, and from one channel enable our user to target multiple channels. Okay, and then long-form text. And so this is where most of the fun currently begins, right? So you have all heard about GPT-3. I'm not going to go there, but what are the problems that we're trying to solve, right? So the first one is when our users are just signing up with Mailchimp, when they are very new with their business, is like they start from scratch. And so they are not sure what to send, what is the first sets of emails they can send. So that's one use case. The second use case is maybe a more sophisticated user that has already a lot of campaign, already a lot of marketing strategy to implement, and now is overwhelmed with the quantity and the variety of all the different emails for the different marketing intent you need to send. So in the first case, you work with very minimum input, right? This is equivalent to the cold start problem where your user just sign up, you know very little about it, and you have to do something, right? The second case is the opposite, where you may have like historical information about the data. You have also some rich contextual information about what's the intent, what you're trying to do there. And this can be used, for example, in the context of a customer journey automation, where you may have like several emails with different characteristics and requirements for each of them. So in that case, you have more data, but also the requirement and the expectation are higher, right? So you need to be even more precise in what you do. So how this is done? Well, it's all about the input prompt. And the GPT-3 or like models have a very flexible input point. In fact, it's also an NLP input point. It's like a conversational input point where you can actually write your query. You can inject the data that you have, maybe about the user, about what you're trying to do, about the specific details that you try, how you want to structure your email, right? before we start, we were curious about GPT-3, what they have learned about the internet. He has been trained on a massive amount of internet data. So we were curious about, okay, what kind of information we can leverage from them. So I'm not going to do this with some specific example of some of our customer. I don't want to receive a call from our privacy team after this talk. So, but we can have we can have fun and ask, okay, what about certain data science in Atlanta? So here you have an example of an improved tone where you write in plain language what you want it, right? You want a description of certain data science in Atlanta. Okay, and you can prompt the model several times. After 4 or 5 examples, the model kind of repeats itself a little bit. And I'll let you read that at your pleasure later, but you can see that the fluency of the model is pretty good, right? However, time to time is injecting fact. And yesterday there was a very nice talk from Tamir that I really appreciate about unearned confidence. Well, here it is, an example where eventually some fact going to be included by the model, but some of them may or may not be accurate, actually, right? So here in example 2, the date of the conference is actually right. But in example 3, he completely made it up, right? Another example is Mailchimp, right? So write a description of Mailchimp. And in that case, the models stay away from like very specific facts like this. And I can review that and tell you that, yeah, it's reasonably accurate for pretty much everything. So here, let's try to do like a more specific example. Let's pick a fictional business, Atlanta Bicycles. And let's say we want a paragraph to spark interest, and then we want a second paragraph more focused on the product itself and add a collection at the end. And that would be the structure of our mail. So how can I create a prompt for that? Well, on the right side, you can see in plain English, you can be very verbose and very specific into what you ask. And as a result, here we go. Et voila. Subject line, an email body. And fluency is pretty good throughout. But here happen again these facts that came up, right? And the question of are they real or not? Are they accurate or not, right? It's very hard to say, actually. It's very hard to detect. So that is really where the model is great. We have seen yesterday, yes, it passed the Turing test. OK, great. But really, in real life, what it takes to bring that to production and really meet the user where they are. So that means that other than the fluency of the language, the relevancy of the language, we have to take some precaution, right, when we want to deploy these things. The first thing is, as much information that we believe are accurate, put them in the prompt, right? That's going to bias the model, and eventually inside the model to repeat this information or use this information as is, right? So prior information is very key, right? Another thing that we have to think about and we're working on is what kind of post-processing you have to do for the output to verify that what is generated is factually correct. And that's a very hard problem to solve. Another thing that came up is like we have to also prevent adversarial input, right? This creates a very large attack surface, right? If let's say you open a free-form input text box for the user to type what he wants, you expose yourself to potentially a lot of trouble. People can enter, for example, a query about competitors or things like that we don't necessarily want to support on our platform. And the final thing is also responsible AI challenge, right? He has been trained on the web with all the good, bad, and ugly things you can find on the web. And that eventually, at some point, will surface. So how we prevent from these different biases to surface is actually an active area of work and for us a big concern. Also, we are very curious about our customer. And so we tested with our customer and do some customer research. We did some blind tests, right? We didn't say it was generated by AI or things like this, and we created several samples of generated text like this for different marketing intent. What we found out was that a large majority of the users, they actually appreciate the quality of it, right? In a blind test, they will say, okay, it's decent eventually, right? Some of them will be more or less harsh, but they have pretty good feedback up front, right? However, they are neutral, if not uncomfortable, saying, yes, I will send it as is, I will close my eyes, right? So there is a notion of control that they want to keep there. Also, we notice that they get hung up on details, and they are very, very careful about what they want to send to their customer, of course, and rightfully so, right? So brands and tone and way of saying certain things really matter to them. And so if some of these details don't match well, their trust is eroding very quickly. Also, what we noticed is that regardless of the quality, regardless of the judgment that they make about the quality, once we reveal them that it's actually generated by AI, then the trust drastically reduces, right? And that's also something that in our community we might accept already, the fact that these kind of models are there. But at large, this is still a very disruptive concept for people, right? And so how we approach the customer experience and the user experience when we introduce this kind of feature is very key, right? All right, and because of that, we also want to look into how we can improve this model, how we can make this model very specific to the domain we are trying to address, right? And this is obviously getting into like fine-tuning this model, right? They have very good generalization capabilities, but how you make them very specific to your domain through fine-tuning. And in the case of marketing, style transfer is very important because style transfer is connected to brand and tone, right? And this is a personality really of your business. So this is where they have a higher level of expectation for these models. So you all know style transfer in computer vision, where you have some content image, right? Some style image, and then you combine the two for an output, right? So what it means in the NLP world, right? So like I just said, it's important for a user for brand and messaging, right? And if we combine tone and brand detection models that are fairly easy to develop, then the question is how you develop AI rephrasing capabilities, right, to make sure that our users stay in brand, for example, right? If they inadvertently write something that is of their brand, we can signal to them and propose them a rephrasing that will be better, right? So the linguistic definition of style is very ambiguous, right? And very subjective, right? There is still the important concept that non-functional linguistic features are classified into style on one hand, and semantic classified into content, right? So there is this division that we would like to try to find in the latent space. So this is more like how, from a data-driven, you will look at it, right? If you compare two texts, the invariance between the two texts is the content, really what the text is about, whereas the variance could be the style, right? And this happens in a very large multi-dimensional space, of course, right? Which lends itself very well with a deep learning method, right? So let's pick an example that is of our interest right now. It's like, for example, formality, informal versus informal, and some simple sentiment transfer. So here you have, handwritten example. I could write that. An expert could write that. This is great. And if I add, per data set that are large enough of high quality, great. I train it. Everyone here knows how to do that, and I will be done. The challenge is that pair data sets are actually hard to find, right, and hard to come by. So the key is like, okay, is there another way to use non-parallel data sets, right, that is more scalable so that I can fine-tune this model in a more flexible way? There is a lot of literature on that for how you can use different parallel data set or non-parallel data set. Today I'm going to highlight one that we are working on right now, which is based on pseudo-parallel corpus techniques, right? I'm going to skip this. This is for your reference, like if you're interested in literature about a parallel data set. But for non-parallel data set, here what we're looking at is like, how can we use so-called pseudo-parallel data? So spoiler alert, there is no free lunch. Eventually, at some point, you end up being a parallel data set. But how we get there, right, is an important piece. So our work is based on a work that Carnegie Mellon University has published about 2 years ago now. And it's based basically on cascading two network. A first network, so-called diverse paraphraser, right? That will take as an input any kind of text and will normalize it. And by normalizing, what it means is that taking out of the text any stylistic element to just focus on the content, right? Interestingly enough, this is what you get when you try to simplify and summarize a text, right? You really focus on what are the core semantic elements and remove all the fluff that might be like stylistics, right? So assuming you have such a network that does that, now from any text you can get down to the semantic dimension, right? And from there, you can cascade a second network that's going to be focusing on injecting back the style you want and only that, right? So that's the basic concept. Well, how you get there? So the first step is to build a small training data set. And the good news is you don't need a lot to fine-tune a model like GPT-3, for example, for that particular task, which is like normalizing or simplifying a text, right? So we use a data set called ParamMT, which is a large corpus of back-translated tests. And how this data set is built is by taking an English test, translating this into another language, and translating it back into the English. And that translation, what gets lost there most of the time is a stylistic element, because this back translation will focus on the content itself. But as I said, it doesn't work all the time, and there is no established definition on what it is. So the paper is great, but it leaves off a lot of practical implementation detail for you to figure out based on maybe your requirement and what you can do. So we come up with basically our own recipe of different metrics to try to evaluate if this back translation is really focusing on normalizing the text, right? So we've done that. We create this small sample data set, fine-tune GPT-3, and then again, what are these metrics, right? So we come up with our own piece, our own method as well, to use a collection of metrics to evaluate, okay, does it do the job of normalizing, neutralizing this style we don't want there, right? So that's the first step. So you have this first model this way. And then the second piece is, okay, what is the next step? And what is the kind of data we need for training the second network, right? And this is where the pseudo-parallel data come from. So here, unlike the first step, it turned out that in practice, you need a lot of data, which in our case actually is not a problem, because we have a lot of campaign data. Mailchimp sending more than 1 billion emails a day. So we have plenty of data, right, for that purpose. And we have also in-house style detection model like tone and formality. So that's not a problem either. And by using this detection model, then we can create a large data set that is very biased for a particular style, let's say, right? So you have that first data set, and then you can use the first model we just developed to normalize, neutralize that, and create the counterpart that is neutral, right? And that's why it's called pseudo-parallel, right? Then you flip it, and you can train, you see it coming, you can train another GPT-3, you can fine-tune another GPT-3 model to train what is the so-called inverse paraphraser. So at that point, obviously, you can bring the two together, right? And start from any input text, normalize it, and restyle it in the way you want. We use open source, in the case of formality, an open source model to test the final output, right? And as you can see, we get like pretty good results for this. So strengths and weakness, performance can approximate supervised model. Yeah, because actually at the end it is supervised, right? So the only caveat is like, can you become good at creating this pseudo-parallel data set? As you have seen before, it's all about what kind of metrics you use to evaluate your results so that you can have a method at scale, right? On the weakness side, it may fail if especially for the second step, right? If you don't have enough data. Right? In our case, it's not a problem, but we notice that. And for the second step, it's also very encouraged to use domain-specific data. If you can use data from your domain, not only you can, train the inverse paraphraser for the tone, but also all other kind of dimension that might be specific to your domain, right? And so in our case, it works well because we have this domain-specific data at scale. But this becomes very important to get high-quality output at the end. So no free lunch there, but some creative way of getting around, labeling and relabeling over and over a large amount of data. I would like to thank my team. All the credits are really for them, and they've done the hard work there. Thank you also, SDSC, for hosting us one more time this year. It was awesome. Thank you very much.